Hey, so we're doing corticosteroids today. So we're going to do a few pathways, so I'm going to move pretty quickly through them. But let's try it out. All right, so first of all, let's just cover the fact that the corticosteroids are produced endogenously by the adrenal glands. That we don't just inject them into the body, they're also just packaged and created by the adrenal glands, and they are packaged and transported into transcortin. Transcortin, which is your chylomicron of corticosteroids. So it's going to move through the blood until it gets to its target. And let's say it gets to this cell here. So it's going to be lipid soluble, so it's going to get into the cell. And one of its pathways I'm going to draw is it's going to act on the machinery of the cell. So there's already a receptor, transmembrane receptor. It's not important what it is, but it's going to basically produce when activated by pro-inflammatory mechanisms, it's going to produce this molecule. This is just an example of what glucocorticoid can do. What corticosteroids can do kind of in a slow gene transcription way. So when the corticosteroid gets into the cell, there are receptors within the cell that are glucocorticoid receptors. I don't think this acronym is quite what you want to be paying attention to, but they will bind, and then they will prevent the transcription of this molecule, this NFKB. If you're one of those people who can't remember NFKB unless you are told exactly what it means, then you're like me. And it is nuclear factor kappa, nuclear factor. I'm just going to write it over here if you don't mind. Nuclear factor kappa light chain enhancer of B cell. So B cells. So that's where this B comes from. That's where this K comes from, the kappa. And it's a nuclear factor. Why nuclear? Because it's in the nuclear part of the cell, the nucleus. So so it's going to prevent this NFKB, which is a pro-inflammatory thing that's going to enhance the activity of B cells, which is an inflammatory response. Now we're going to draw another cell here, and I'm practicing drawing cells the ways that I would like to. So let's see if we can do this here. It's going to be a fun experiment. This is how I like to draw bilipid membranes, lipid bilayer. So first I'm going to draw a wave at a frequency that I think I can maintain, and then I'm going to try to shift it and draw the phospholipid heads. That looks terrible. So let's try another one. Okay, I'm trying to make it so that the peak, uh-oh, my computer doesn't like that at all, so that the peak hits every single one of these little guys, and it's just not working. You can see on the other side, if you paid a little more close attention, it looks pretty good. Okay, so this is a lipid bilayer, and now we're going to switch to black because this is another pathway. So this transcortin coming from the adrenal gland is also going to take a trip over here, and when it does, it's going to act on this lipid bilayer, which also has these esterified arachidonic acid. Okay. Terrible handwriting. Arachidonic acid. So that's something that that ordinarily arachidonic acid during inflammatory response would be cleaved by phospholipase C, and phospholipase C will result in this, like, what, cytosolic arachidonic acid, right? ARAC, which is a liquor in Middle East. Okay, so Arak is then cytosolic, and I don't know why I wrote this because I don't have enough room, but let's pretend that this is part of the cell. And then this free arachidonic acid will go to a COX enzyme, which produces things like PGE2, you know, PGI. It'll produce things like thromboxane A2, a bunch of pro-inflammatory BS. And then it'll also produce leukotrienes, right? You remember this pathway. And so leukotrienes are bronchoconstrictive. So cool. So what winds up happening is when this transcortic molecule starts coming down into this cell, because it's lipid soluble, it goes right into the cell, and it produces this molecule called annexin. And annexin, I know this is terrible and not easy to read, is going to inhibit the phospholipase. And when it does, it's going to prevent this free cytosolic arachidonic acid from going and producing these pro-inflammatory molecules. So that's another action that's much faster. So annexin coming from the corticosteroid hormone. So let's talk about these two pathways real quick. First, you have the adrenal glands producing transcortin, which I wrote with a C for no reason. Transcortin, okay, and then transcortin goes down this way. Strike that. Let's go this way first. It goes down this way, and it's going to result in annexin some way, and then it's going to block this PLC from producing cytosolic arachidonic acid. Okay, and then you prevent COX and you prevent leukotrienes. Okay, another pathway is you have the adrenal glands, you go to the transcortin, comes down, and it binds this corticosteroid receptor, glucocorticosteroid receptor, which is going to block the NFKB, which is the nuclear factor kappa light chain enhancer of B cells, and that's going to be an anti-inflammatory effect. Okay, so you get, if you're taking these for a long period of time, corticosteroids, you're going to get potentially immunosuppression, right? Because you're blocking them in two different ways. Okay, and so, and one of these ways is in the nucleus. You know, it's a slow process, but it is going to reside in that person for a while. So anyway, another thing that you can have is, just as a side note, is in your bones, osteoclasts are inhibited by corticosteroids. And so that's why you get osteopenia, because you actually aren't storing the calcium that you're eating in your bones, which is how you store a lot of your calcium. And so your osteoclasts are just, you know, they're inhibited by the corticosteroids.